Hi everyone, a very good morning to all of you, and welcome to the session by Digital Vidya. We have the topic for today's session as cognitive process automation using machine learning. And in today's session, we'll start with the overview of intelligent automation journey from robotic processes to automation towards cognitive automation using machine learning and AI. Then we'll focus on understanding what kind of automation best suits a business, followed by some use cases. And for leading the session, we have Harihar Sudhan, who is a data scientist and technology consultant based out in Singapore. He will be briefing us through with his experience and his learning over the past many years. And we'll take up all the questions in the end of the session, and simultaneously we'll look into the questions and pick up while we are in the session. So feel free to put in all your questions in the chat panel on the right hand side of your screen. And over to you, Hari. Thank you.
Thanks, Divya. Is everybody able to see my screen? Okay.
Yes, they can.
I hope. Okay, great. Divya, can we start with questions, poll questions, so that I can get an understanding of what's our audience, so I can decide on what I can speak. And yeah.
Sure. So we'll put in the very first question on the screen, and please select everyone that whether you are a student or a working professional at present. We have got some responses. Around 64% of the people have already polled in, and you still have 10 seconds for this particular poll. Here we go.
Okay.
So around 40% are students and rest 60% are working professionals.
Okay.
And moving to next question, I want all of you to put in which industry you belong to, if you are from an IT industry or a research company or others, if it's a mix of other profile. So giving out another 15 seconds for this poll. Yep. So here are the results. 73% belongs to IT industry, 9% are from research, and rest 18% are from other industry backgrounds.
Okay.
Next question is, how many years of experience do you have? We'll give out another 20 seconds for this poll. We have got 80% of the responses already. So 55% have less than 2 years of experience, around 80% belongs to 2 to 5 years category, and the rest 27% audience is from 5+ years of experience.
Okay.
Putting in the second last question, have you experienced or done any process automation before? So we have received around 80% responses till now. Another 5 seconds. And here are the results. So 40% haven't done any process automation. Rest 60% of the audience have done process automation before. Putting in the last question, have you ever used machine learning before? Here are the responses. Around 30% have used machine learning before, while 70% of the people have not used machine learning before.
Okay.
So I think
Okay.
uh,
This, thank you, Divya, for the questions. Now that I have some good idea about the audience, most of them are in IT, while some from others, and most of them are less than 2 years experience. And like 70% of people haven't used machine learning before. And on process automation, it's an equal distribution almost. Half of the people have used something. I'll try to keep my presentation, whatever I speak, to to address the less than 2 years experienced people, while I can speak something technical which I feel might be useful for experienced people as well. Feel free to post your questions in the questions panel. I'll take the questions later, and I'll see if I can take any questions while I speak. If it's related to that particular slide, I'll try to take that as I speak. Uh, Lost the audio. I see a question that lost the audio. Uh,
we can hear you.
am I audible?
Yes, you are. We'll figure out with the person and help him out.
Okay, okay, fine. So, cognitive process automation. The term might be very fancy here, but it is otherwise can be also called as intelligent process automation. It is a journey. What I would say about cognitive process automation is that it starts from a very basic level, which is called robotic process automation, otherwise called RPA, famously known. In RPA, all the automation process will be rule based, and anything that cannot be fit in rules, RPA will not be able to handle those automation processes. And before we start into this presentation and speak more about what is this journey about and how does it evolve, what are the techniques that can be used for processes, and what are some key things to keep in mind while implementing any of this RPA or cognitive process automation projects. We should understand one thing. In most places, people misunderstand application automation and process automation. That is, many of us write codes. Most of us are 70% audience is working in IT, so I believe most of you would write codes in your preferred language. When we write code, there'll be a lot of chunks of codes which we will then use one after the other. For at some point of time, we will have multiple chunks of codes which has to be executed one after the other. In that case, we will start automating those chunks of codes. Like we may choose to have a command line script which executes 5 of my query, all are on same programming language or maybe different programming language. Let's say I have a first piece of code in Python programming language, and then I have my second piece of code in R language. So if my whole pipeline is like 5 steps, one after the other, everything has to be sequentially executed, then I might choose to have a command line script which automates the process of this 5 step by itself. That itself is considered as an application automation. Whatever codes I write, which is a piece of software, for my convenience, I'm just trying to automate that piece of software is considered application automation. It is not process automation. On the other case, in any industry, I have a lot of processes, and there might be repetitive processes. There might be processes that needs human skills to a certain level to execute tasks, and these processes are time consuming. If we identify those processes and try using programming or tools outside like RPA tools to automate the process and eliminate the manual intervention that is classified in process automation. So when I say cognitive process automation, it evolves from basic robotic process automation into a second level of advanced automation and a third level of cognitive automation, which is otherwise called intelligent automation. Uh, when it goes to second and third stages, we will be using few cognitive technologies to supplement our automation process. That is why it is referred as cognitive process automation. We'll move into the presentation. So what we will see, we will be discussing about in this webinar is we will see some of the common questions from organizations in this area, from actual industries across the world on what automations they can do, what they feel, what is their major questions, and then we will see the cognitive automation journey. Most parts of this presentation will be conceptual. We will try to understand the concepts and industry cases, while we will not see anything on the technical side. Mm. And then we will see something about how AI complements RPA. Then we see some use cases and some statistics on process automations and what level of process automation, how many percent of companies are doing cognitive automation, and so. Then we will see what some one slide on most automatable and least automatable business processes, and we will see key steps to keep in mind while implementing any of these projects. These are hard learned steps, like when we implemented projects, whatever we faced, and what are the best things to keep in mind before implementing. So if we see the common questions, most of the company doesn't know where they can start their automation journey. Should they start like a basic rule-based automation, or should they start with something that has AI or machine learning in it? Most of them doesn't even know if RPA can solve this problem or not. For example, in one of the recent conferences where I've been, I met few people. One person, particularly from a pharma company, reached out to me asking that they have all this manual way of deciding uh, which deliveries has to be done today based on the inventory available, how they can manage the inventory, everything. So all this time they are doing this with paper. They start doing the estimations with paper on what is their inventory, which client is preferable, which client's order has to be delivered first. So if I don't have enough stocks today or this week, this month, who can I ask to wait, or who should I not ask to wait, and which delivery has to be first? Everything is being manual there, and the delivery sequence is who has first come first serve basis or order of priority. Everything they're manually doing. They reached out to me and they asked me about like, is there a way that we can solve this? This is consuming so much time. Like for every order page they process, it takes like 10 to 15 minutes for them. And in a day, they are like processing few hundreds of uh, papers, records, or orders. So that is a lot of time, and it is done manually, which has the possibility of manual errors. Um, so that is the stage with most of the companies. They are having a lot of processes as part of their business, and they are a bit away from technology, and they want to know that where can I start my intelligent automation or just automation journey. And then the next question which I see from most of my clients is like, what I am doing some automation here. I have some rule-based engines, rule-based systems that can do some automation for me. But what next? I have the rules. I have something which is rule-based. Is that all in automation? Can I do something else after this, or there's no more growth after this? That is another question which I get from most of my clients, and they also asked me many times about how AI or RPA are linked together. Artificial intelligence or machine learning, how is it involved with automation? Automation is programming and just making some manual work or manual work into an automated work. But how does AI comes in? Where does machine learning helps this? Does AI complements AI complements automation, or is it otherwise? All these kind of questions. And some people specifically ask, like, my competitors are. I heard that my competitors are using AI, and then should I use it, or am I not using it now? If I'm not using it now, am I late? Like, will I be losing my market? All these questions. This just for you to give an understanding of how the market is, what's with the customers, what are the questions they have. So if you are looking into mm, speaking with customers on understanding or identifying automation opportunities, then you should be aware that these are some questions which they might have. They mostly, or definitely, I would say, they have these questions. So you, because we tech people, we understand automation, everything. We just can't go start speaking with these customers on, okay, I have this, I have that. Can you do that? It is not feasible. For them, it will be like Greek and Latin. So we should understand their level, what based on these questions, and start from the basic of what asking what is their problem, what is the existing process, and then do a feasibility analysis on if you can do any automation for any of those processes and come up with an estimation of value. If you do that, how much time or money is going to be saved, and then proceed with the projects. Okay. So when I say cognitive automation journey or intelligent automation journey, as you can see in this slide, uh, as we can see in this slide, the basic is like no automation level, and then they start doing basic automation, that is robotic process automation, otherwise called RPA. In case of RPA, what can be done is all repetitive tasks can be handled by RPA, and then all those automations will be simple actions, like very much rule based, structured. If there is no structured data, let's say if there is a data entry work, it can be automated because it's very structured. You can point the location where you can find the data, or if it is, let's say if there is a company, let's say there is a company whose structure has changed, the organization structure changed. Like they had three verticals, now they have converted into four verticals. They split something here and they shuffled it. So employees will be moved between the verticals, and they need to move or transform all the employee related data into a different structure of folders. So that, imagine for this problem for a bigger company, like one of my clients who is a big telco company faced this. They are like few thousands of employees. If, let's say every employee has a folder inside which his files are being managed. This process is repetitive, like somebody has to copy everything based on an Excel file, maybe, where the Excel file will have the employees uh, name or ID, the previous hierarchy folder, and then the current hierarchy folder. Then it has to be moved manually in olden days. Like they move it manually from here and there, and there are a lot of possibilities that they move it to a different folder, which creates a lot of problems. So these are some examples of processes which can be automated with basic robotic process automation. We just code something, script something, or use some RPA tools to point out everything, feed in the Excel files, and then everything will be done by the machine very fast. It is efficient, time saving. And on the other side, RPA, the basic automation processes, which are rule based, will pull jobs, because a lot of this kind of jobs handled by people, if we are automating that, then uh, this will pull a lot of jobs. While if we go higher from here to advanced automation stage, it has a lot of variable actions involved. Like the data could be unstructured. Why do we need to go to the second and third phases from the first phase of RPA? Is because if we go beyond structured data, let's say we go for an image, then rule-based automation systems, the RPA tools around there will not be able to handle any of those unstructured data. So that's where we start bringing in artificial intelligence capabilities and machine learning capabilities to handle a higher complexity problem. Um, so in the middle phase, in advanced automation, uh, let's take a case of image. Let's take a case of um, taxi claims or any flight claims or whatever bills you have, you are claiming it. Uh, every company will have a process of claim where you will submit your claims and then also submit your bill, photo of it, an image of your bills, and there is someone who verifies it and approves it. So how does it work? Someone's opening all the things and then see the value you enter, the flight bills, everything matches or not, all those things. These are some processes which can still be automated because it is repetitive. It is the same process. Only thing is that the image has to be converted into some form of information. Some information has to be extracted from the image and then it has to be compared with the values you feed in your claim forms or something. So in this case, how could we solve it is like to bring in some of the advanced image processing capabilities like OCR, which is called optical character recognition. If we bring that, we can feed in images where the OCR engines will read information from the images, like it can extract the the amount of the bill or the final amount and everything, and can compare with whatever you feed it in. It can approve it if it works out. So this whole process can be automated. In this case, it will not be classified as RPA because we are bringing in complex technologies, a little bit complex technologies inside to handle this requirement. And going beyond that is the phase where we need some interactions when we automate the processes. That is classified as cognitive automation or intelligent automation, where a lot of tasks involves understanding something from the data that exists so that the process can be automated. If there is no understanding, then the process cannot be automated. And it can be from any data format. It could be something from a PDF or a video or an image or structured data or NoSQL data, which is no non-structured data. And in that cases, that's when we bring highly advanced artificial intelligence capabilities and machine learning, especially to learn patterns from the data. One example which I could say for you to imagine is one of my clients who was in mining industry. They mine ores and then they they ship the ores to the customer places. So when shipping, they don't have their own ships. So they have to rent the ships from the vendors, where there might be multiple vendors who will ask a different price for the shipment. Usually, how that works is the ores will be shipped in tons, and the charges will be charged per ton. In that case, when they need any shipping, when they need new vessels or new ships, they will go negotiate with all the vendors whose ships are available now, and everybody will ask for a price, and then a negotiation process will go on to decide a final shipment price, which is called freight charges. Uh, so for this particular problem, there is a long process involved because the when a ship is empty, it is like in the sea. There could be external calamities or any other external factors that affects the arrival time of the ship, when the ship will reach and how far it is away from, and it is based on the requirements. There might be too many ships available someday, there might be very less number of ships available on other day. So everything has to be looked into so that the business, the mining company can come up with the final number in their mind that okay, this is the price that I can go with. So I cannot go beyond this price, and I'm taking this finalized number, which some of my experts sit in a room, discuss together, and come up with that number. Okay, last week the price was this many vessels are available. This week, okay, this many vessels are available, and I need this much tons to be transported, and my urgency is this. I have to transport all this by now, by this time, so I need the ship. So okay, I can go for like $10 today. For this shipment, I can go up to $10 or $15 per ton. This is very manual. In this case, if we want to automate this process, we then need to bring in some kind of machine learning where all the data, including the vessels available, which can be pulled in by API calls from third-party vendors who supply data about where the ships are currently, any ship that are currently in any location in the ocean, we can get that in real time by from third-party vendors. So somehow we need to come up with some form of data preparations, data acquisitions on the availabilities of vessels, and then we also need to come up with other external factors like how much ore do I have, how much ore I need to send from my mining site to the customer's place, where it is going, and everything. All this data will be passed in, and the records of historical prices, say for the past 2 years, what has been the freight charges, what has been the transportation costs for me per ton. Everything will be fed into some kind of machine learning models, which will then start learning some patterns from this, which we will then extrapolate to predict a value, an optimum value by the machine learning algorithm. And then that value will be taken by the experts with a level of confidence which is also given by the machine learning systems. So that is where highly complex machine learning and AI comes in the process of in automating the processes. This whole process, if done manually, involves a lot of people's time, experts' time to be involved, and everybody will have some human bias. Let's say I am an expert sitting in a panel of for a discussion on this case, then I will have my bias that if the number of vessels available is the most important thing that causes the price. So I might come up with one number which is biased towards my opinion. So everybody will have their own bias, and the final result will also, it is based on experts, based on their experience and expertise, but still it will have a biased component. By bringing in machine learning here, we can automate the whole process, which will then act as a complement to these business experts, while um, the machine learning algorithms will churn out the value to them with uh, with with explanations of how they are deriving this number and how much they are confident on this number, which will be which can be directly taken if they are very confident on the algorithm trained, or other case if they are not, if they are skeptical about the technology, the machine learning, how can it rely on this number, they can take this number to validate against the number which they come up. So why is it very important? Because in this process, if they save even 10 cents for every ton, for their millions of tons that is shipped, they will be saving millions of dollars. So this kind of processes or the opportunities where machine learning or AI can come into play, that's when it becomes intelligent automation. So I believe that we now have some understanding on what is process automation and what is basic robotic process automation. How does machine learning comes in? What is the journey? How does a normal automation task with complex technologies becomes an intelligent automation task? So is everyone clear until now? Can someone text in if you have any questions? Can you text in the question box? Okay, I can see clear. Fine. Please feel free to post your questions if you have any questions until here, because if you understand this, it'll be easier. Moving forward, uh, let's try to understand what a traditional RPA does. What I was saying, it's almost the same in the slide. Uh, Basic traditional robotic process automation or the basic automation is utilizing robots to perform transactional and repetitive or rule-based actions in a digital environment. That is, we replace manual efforts with uh, robots, and it is applicable to a largest part of uh, automated process activities. Like most of the companies, they will definitely have some room for basic rule-based automations. But that's not what we are looking at here. We are looking at cognitive automation. We'll speak more about it. So the advantages of RPA, why people want to go for automation and RPA, is because it is cost saving, it is very easy to implement, and it improves quality and accuracy. They will be able to see value immediately when they implement rule-based automations. Um, because in repetitive tasks like rule-based tasks, or for example, the task which I said where we of organization structure is changed, copying the employee details to a different structure, they can evidently see value immediately when they implement this automation. So that is why most of the companies choose to start their journey with basic rule-based automations. Yet it is not a hard rule that they have to start with basic rule-based automations. They can directly, if there is a use case that is found valuable um, for the company, they can start anywhere in this whole journey which we saw earlier. They can start from in the middle phase, which is advanced automation, or they can choose to start with higher complex machine learning or AI uh, involved automations. Uh, so as I was saying earlier, why does machine learning AI comes into this automation thing is because of the limitations of simple rule-based automations. Um, I have a question, which is how RPA and intelligent process automation aid in test automation, automation testing on routine process. Can we value to automation testing with RPA? Okay, we test test automation is a different thing. I would normally I won't classify that into process automation. Automation itself is a domain, and if your question is there a way of bringing in machine learning for test automations? Yes, there are ways. It is a bit away from today's topic, but then the answer is yes. If you want to look more, you can search for machine learning for automated test script generations to start with. That would be one easier thing. You can find research articles on that and then start reading it. Difference between machine learning and data science. Machine learning uh, is a is a part of data science. Data science is something that anything you deal with data, you can classify it as data science. Maybe a simple visualization from the data is still considered as data science. It is in it is a science that it is data visualization, but it falls inside data science. There are different people with segmenting data science into multiple categories. For understanding, I would say three major things in data science is data engineering, data uh, machine learning or data scientist work, and then data visualization work. So it could be either on efficient handling of data storage and retrieval will be in data engineering side. What comes in the data science side, data scientist side, which is referred as data science side most of the time, but then it's the work of a data scientist is to build algorithms um, that can learn patterns and uh, things from the past history, or uh, basically learn something from the existing data to extrapolate or predict something which is going to happen. And on the other side, data analyst job, which is data visualization. These three are all inside data science. Moving on, what are the techniques from AI and machine learning that comes inside this cognitive automation journey? You can see on the slide. It can be natural language processing, where for one simple example could be a chatbot. Uh, we can nowadays see in a lot of websites we have an automated bot that can answer basic questions to you. It could also be rule based, but some of the bots will be natural language processing. What does natural language processing mean is a normal human language that is processed by the computers with some programs to do some language understanding. Uh, in 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 a basic case, NLP, some people refer to syntax-based text processing as NLP, which is like some of the bots, when you ask some questions to some of the bots in the websites, it will read the question and then it look for some particular words, syntax-based. And if the word is there, it will then give you a whole big paragraph of answer, which you have to read and then find the answer which you are looking for. That they refer it as NLP, but it is a very basic level. But in actual, what is NLP is language understanding. It has to go beyond syntax level into a semantic level, meaning based level. There has to be processings like parts of speech tagging, and then based on the tagged parts of speech, uh, information has to be extracted, and similarly and then it has to be represented in a sentence case as just like how I would answer you in a text if you ask me a question. That is the highest level of NLP, which is very much used in this cognitive automation processes in many places. Still, a lot of it is in research area because it is very difficult to process natural language. A lot of ambiguity will be there. Everything has to be handled. And the other one is image analysis. As we were speaking, OCR is one thing, and machine learning and deep learning algorithms, which are deep learning is nothing but neural networks, if you know about that. Um, Machine learning has a lot of algorithms in it, one of which is neural network, which tries to replicate human brain. It tries to mimic how human thinks on things and understands things. But in olden days, there was not enough computation power. So there has to be some limitation of how many neurons that can be used and how many layers of neurons can be used in an algorithm. But now with advancements in technology, computational power has become cheaper and more power is available. So people started implementing more number of layers and more number of neurons, which then called as deep learning. So which is nothing but one algorithm, neural network, which is also a part of machine learning, just for understanding. And then predictive analytics, which is learn some patterns from history and then try to extrapolate the pattern um, in to predict something that's going to happen in future, so that the businesses can take preventive actions or rely on this number to come up with some decisions that help them. Um, Let me answer some of the questions here. Meanwhile, programming tool widely used for machine learning is Python and R programming, equally used. You can go with whatever you like. And briefly explain any process automation using suitable ML algorithm. We'll speak more about it. Okay, related to job, we'll take it at the end. Um, okay, let's move on to the next slide. What you see here now is a flow of basic rule-based automation process. It's the same case which I was saying earlier. Organizational structure change. If that happens, how we used to solve it before earlier is to have a have an employee who manually moves all the data to a different newer structure, and now after automation, it'll be like how it is represented below. There will be a bot that will do the job faster. Let's say a person does it in 1 week, the bot can do it in like 4 or 5 hours of time without any error. That's the advantage here. On the right side, if you see advanced automation, that is the case which we were discussing earlier, optical character recognition in the claims thing. It's just a representation of how it works, how the flow will be. I think we covered this. So just for you to have a look at the process, we'll move on to the next slide. Here comes the intelligent automation. Let's take a case. I have built a case here, so it'll be easy for understanding how does an intelligent automation or cognitive automation work and how much it is useful. Um, let's take this case. Without an intelligent system, if we go to a doctor uh, for some illness, the doctor will usually examine us and then he records the results. In case of severe cases like for example cancer or something, the doctor will then consult with peers and comes up with some familiar treatment protocols, maybe 5 or 6 cases he would consider, and out of the 5 or 6 familiar treatment protocols, whichever he feels better for this patient, he would recommend a treatment plan. This is very generic flow for any illness, for anything we visit a doctor. This is the process that is happening currently. And what are the biases we see here, or what are the problems we see here is uh, the doctor is examining. We can find one thing, like the doctor will start asking questions to us, and based on every answer, he would decide his next question. From a techie view, what is happening behind this process is the doctor is accumulating information, and then the answer for one question is different, then his next question will be different. If you know about what is a decision tree, that is the process happening here. So there is a decision tree which has a first question, and then there can be multiple answers to it. Based on the answer, it will then move to a different node in the second level, and based on that answer it will move to a different node all the way until the leaf node. So there are many leaf nodes that are decided, and whichever leaf node you go at the end, uh, famous treatment protocols for that end will be considered, and out of the 5 or 6 famous treatments which the doctor considers, you might get one recommended plan. But on the other hand, there might be like few hundreds of treatment protocols for the same problem, and the doctor might be biased on building his decision tree. A lot of these things are there. Uh, so when we bring in intelligent systems, how could that be solved? In fact, this is being implemented in many places. There is one implementation of this case in Singapore, which exists in a famous hospital, where when the doctor examines things and then he feeds the results into the system, the computer system will be able to go back and refer to all the previous cases which are similar to this case. Let's say, let's take a case of cancer reoccurrence. In that case, if the doctor needs to find based on the test results, that is there a possibility for this person who was treated for cancer to have a reoccurrence of cancer. if a doctor does it, it is a bit vague, but the system will have information on all the historical patients who were treated for cancer and how many of them, which one exactly has had reoccurrence of cancer, which one did not have, and all their behavioral characteristics and demographic characteristics. Everything will be recorded as part of um, the hospital records. If we feed that record and then the new patient's information to the system will be able to like consider thousands of cases before, learn a pattern from who actually is having a higher risk of getting the reoccurring cancer, and then use that pattern and applies the new data of the new patient into that pattern and see and tell us that if he is high risk, if he is likely to get, and how much confident the machine learning algorithm is on the result which it says. Let's say, for example, it can say one possible outcome is like, yes, this person is um, at risk, and I am like 80% confident on this. So there are ways in machine learning where we learn patterns, and then based on the there is something called training, and where we feed in a lot of data, in this case past historical patient records. We will train the model, and how much it is trained, is it trained well or not, can be evaluated from the model. So after some logic processing from there, we will be able to come up with how much confident the model is on this result. So on this process, when we train a model for predicting if there is a possibility of reoccurrence of cancer, the model will be able to give us the result which it thinks, and then the confidence. In some cases, the model will still tell us that yes, he might get, but I'm only 30% confident. It is still okay. On the other hand, model can say like, yeah, I think he will not get cancer again. It won't reoccur, but I'm only 20% confident. Think about that case. If that happens, the result is no. Just because it is no, it cannot be left out, because it's only 20% confidence. So because it can come up with the confidence measure as well, this whole system can act as a decision support system for the doctors. While we cannot hand over a patient's health to a machine, that is a concern, but we can leverage this kind of systems to suggest the doctor with maybe a better treatment protocol from hundreds of protocols out there which are fed in the knowledge base. Or maybe the doctor thinks no, the system also tells no, but the system tells I'm only 20% confident on it. Um, then the doctor can use this information to validate his intuitions, or a group of doctors, after their discussion in a panel, they can still use the system to validate their intuitions and then make changes to their decisions. Maybe after it recommends a better protocol from the knowledge base which it can retrieve, the doctor might even feel like, yeah, that sounds better, even I didn't consider, maybe because it's not possible for a doctor to consider all possible treatment plans. Let's say if there are hundreds of treatments, it won't. You might have seen like you go to one doctor every time, he would give a different medicine for cold, while the other doctor would give a different medicine for cold, because it's his practice, it's his intuition. Uh, so that is the level of uh, complexity we are looking at, the benefits we are looking at. It is not only automating and a process that involves a human expertise, but it gives the advantage of being more accurate, being considering more possibilities, and then reducing errors, eliminating errors, I would say. So that is one example of cognitive automation. So when I said cognitive automation, this is what I meant. How does machine learning helps is this kind of operation. This is one case, but on the other hand, the other example which I said for a mining company on the shipping charges, the freight charges, it is still cognitive intelligence. automation, because the process is being automated. We are using machine learning algorithm. We are bringing in a lot of external factors that contribute to the price, including the fuel price for on that day, and then operation charges on the ship, how many employees are working, everything will come in, and then everything will be fed to the model. The model will be able to learn something from there. It will be able to give us a better or very much generalized prediction for that problem. So what I want to say from here is, when we see when we were speaking about the basic automation process, it is very much straightforward, rule based. It can be implemented just like that. It doesn't have any judgmental things involved. There is only rules. There is no judgments or intuitions involved. So at that place, this kind of automation systems can act like, excuse me, have you booked this room? Can I use the room for?
Sunlight, Sana, second.
I'm in a meeting. Can I speak to you later?
Okay, no, it's fine. It's on.
Okay. Thanks. Sorry about that. I had people visiting the meeting room. Okay. What was I saying? So in that level, in RPA case, the system can pull jobs. It can be a direct replacement for the manual efforts, while when the journey moves from a rule based thing to a judgment based or intuition based problem, the systems will not be able to replace the man or human involved, while it it slowly moves into a decision support system instead of being a replacement of some existing process. But there might be a question like, if it does not replace the process, if it does not replace the the person who is actually doing it, so how does it help then? So if that is the question, it still helps, because for most of the businesses, bigger businesses, it is not only saving time, but it is the quality which they can get, it is the accuracy they can get, it is the experience that they can give to their customers. In retail, mostly it's experience. um, so anything that supports decision making is a harder part in bigger businesses. uh, so anything that supports businesses with strong facts that are backed up with data, that is real value. In case of the shipping charge example, as I said, if the system can act as a decision support system and give a value of like, you are think let's say the people in the panel come up with a number like $8, but the system says like $7.50, with a 90% confidence backed by data, then they can like revalidate, and maybe they can decide like, okay, let me not stay in 8, let me come down to $7.80, and there is a 20 cents difference which the system has gained for every single ton they are transporting. So that's the value on 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 this kind of advanced systems. Let me try to answer some questions now. Apart from pharma, what are other domains? Example, banking, airlines, intelligent automation is implemented. We will see about that. We have a slide on how much percentage of people are using uh, automation. But industries, there are opportunities in almost all industries. Um, that is where we are going towards. Excuse me again.
I'm going to check something.
Now, in the middle of
You will just do for a while. It won't take so long. Because we blocked out all this forum here to do some debate soon.
Thanks. Can I sit here? Can I proceed? It's a webinar. I'm speaking. Thanks. Sorry about that. I had some people doing some work here. here. So moving on, the current slide which you see here uh, is some statistics on how many percent of organizations are using some level of automations. If you see, 9% of organizations in which are in this is a survey conducted in all the companies involved. 9% of the companies did not do any level of automations, while 12% of them were doing some intelligent automation, which is cognitive automation things, and 27% on advanced automation, 52% on basic automations. And on the right side, you can see that 91% of organizations who are doing some some process in some level of automation, be it basic or advanced, whatever it is, but they are involved in some kind of automation. But the interesting fact is that if you see the last point there, out of all the organizations who are doing cognitive automation or intelligent automation, 92% of them have mentioned that they are able to manage their organizational changes very well, uh, which is which is like uh, they this result gives us a confidence that this kind of cognitive automation solutions are really helping organizations to handle a lot of judgment based decisions, judgment based things, organizational changes, all those areas. Why but on the other hand, if you see, only 12% of them are using cognitive automation, while most of them are looking into the basic automation phases. That is because uh, when we when we move in this journey from no automation towards an intelligent automation or cognitive automation, the implementation cost and complexity is higher. So as you can see here, the x-axis and y-axis, every single phase you move will have higher complexity and involves a higher cost. So there has to be a lot of decisions, and most of these advanced or cognitive automations are more like black boxes. When I say artificial intelligence, and when I go and say customer that machine learning algorithms, which for them feels like some black boxes which I'm going to rely on. I'm going to invest on some kind of a research or a testing or R&D, which I'm going to try out if it works or not. So if that's the case, basic automation does not cost so much. So a lot of organization can try this, can spend money on basic automations, while implementing a machine learning algorithm or a higher level of AI needs a lot of money involved, and there is no guarantee for them that it would work out. So a lot of people will be very skeptical about it. They would feel like, what if I invest a lot of time and money on this, and if it doesn't give me enough uh, uh, returns? That will be a question. That is the main reason that most of people are not trying out any any cognitive automation things right now. But on the other side, when they start from their basic automation, they will see the returns, and then it'll give them confidence on moving to the next level. And that's when one of those questions comes from the customers, which is, i have I have done some RPA basic automations, I'm doing it in my industry, what's next, what can I do after this? So that is when you can think about what is the next things, how you can automate some processes which involves a lot of human involvement, judgment based, all those things come into play, and then they start implementing. Though this number is 12% now, it will eventually grow into a higher number in future, because the more companies invest in cognitive automation and then they see value, it will be published around, and other companies would see that, and everybody will also have a fear of, my competitor is using it, and should I use it or not? And the answer is, like, if it's useful, you have to use it. It's not because competitor is using it, I have to use it. And in most of the cases, it is found useful. if there is a valid case, it will be useful. So that this representation of number would change in future, because more and more companies will visibly and see the benefits of those systems. They will be, they will not be skeptical like how they are now. So that is the thing. And yeah, the question was other domains. As I said, every domain, if you say 12% here, they will be like very minor number of domains. It doesn't mean that there is no opportunity on the other domains. They have not explored it yet. But if you look for opportunities, the way we do it is like you go to the users and start asking the user stories on what are the problems they are facing in their business every day. And you will get a numerous views, number of views from many different users, and from there you filter out something which can be done with technology. You have to understand the technology for that. If once you understand that, you will then be able to propose what you can do. And if you manage to give the confidence that the system can help them really, they will start doing it. So every single domain will have opportunities in this space. The thing is, you need time and understanding of the business and processes and technology to actually build a case on top of it. And the cases you build has to be backed up with a value estimation, um, which is what I was saying when I started the presentation. So it has to go with the value estimation, and if it is justified to the company that the value they get will be more than the cost uh, they are going to incur, the project will go on. So moving on to the most automatable business processes and least ones. As you can see on the left side, the most automated processes are like payroll processing, managing logistics, and managing warehouses, customer services, uh, processing account payables, expenses, claims, all those things. You can see one common thing in all these kind of processes is that they are all like mostly rule based, and they don't, the main thing is they don't involve any judgmental things. They don't involve any human human knowledge, or too much of the human knowledge or judgment on this. While contradictorily, on the right side, the least automatable processes which you can see are developing visions, decisions on disposing of assets, when to happen, external relationship management, employee relations, all those things. These are harder things because it involves human knowledge. It involves judgments. Um, so that is why these are least automatable. As you can see, and as I was saying in the previous slides before, uh, only 12% of people are on those areas, those intelligent automation areas. And whatever you see on the right side are the ones which will be on the cognitive automation area. Whatever you see on the left side will fall in the basic automation. So when we speak about cognitive automation, we are going to deal with judgment related activities, judgment related processes, which makes sense that at this point of time, very less number of organizations are actually using it. But the more and more organizations and use cases come out, everybody will start using it. The actual potential of this domain will be realized, and there will be more researchers, R&Ds, and actual implementations of cognitive automation. I hope I answered some questions with this slide on examples of different areas and domains. Um, and let me see if I have any questions related to it. To get a job as machine learning engineer, is it necessary to be a good competitive programmer? Uh, Machine learning engineers are okay. There are some casual usage of the role names here. Um, People who does use some tools, existing tools, which they can open and then feed in the data, ask the tool to do the work. The tool will do something, and they will get the results from the tool. They demonstrate the results. They are still called as machine learning engineers. It depends on what kind of role in which company you're looking for. But in my view, a machine learning engineer should be good in scripting, not programming. They don't need to have a full-fledged programming language experience or expertise, but scripting languages like Python. Um, Very important things for machine learning engineers is they should be good in math, or they should improve their math, and some statistical analysis. Math, I would say mathematics is very important to be like a machine learning engineer, because you need to deal with a lot of maths behind every algorithm. Not all the processes a machine learning engineer faces can be solved using tools. Can Not all the problems can be solved with default available chunks of codes or library functions which are available outside. There are cases where you need to go deep behind the algorithm, open the actual codes from within the libraries and see how they work, make or um, tweak the algorithms sometimes, or understand few of the algorithms based on from the codes, and then come up with a mix of them as your own algorithm for a specific case which you are trying to solve. It is required in cases. On the other side, even if you are using default algorithms from existing libraries and so, then you still need to understand the algorithms. Machine learning engineer should understand the algorithm first before start implementing it using tools. But sadly, it's happening the other way. Most of the places where they teach this, they start with some tools and they teach people to implement an algorithm before even explaining or trying to make the learners understand the algorithm. Because when you understand the algorithms, it's easier for you. You can go with any tool, doesn't take more time. Hardly it will take 1 or 2 months for you to learn the programming language or tool. While if you know the concept, you will be able to implement that in any language. On the other hand, you know the tools, you will not be able to explain it, you will not be able to tweak it. um, where even if you use default algorithms from the libraries, you still need to change the parameters. You should know which parameters has to be changed, the hyperparameters. It's called hyperparameters, which are something like when you train a machine learning algorithm, how fast it should learn, how many data points or how many factors it has to consider, all this kind of um, changes. There could be different numbers for it. You can play around with the number. It could be trial and error, but still it should come heuristically. You should understand the algorithm so that you will be able to try out different heuristics, or those are the essential things to become a better machine learning engineer. To get a job, that's a different case. If I need to implement automation for to mine, how much it cost approximately? Um, I can't say the cost approximately because different industries have different problems. It depends on the problem, the amount of data you're seeing at, the variety of data which you are going to handle. Uh, Say, if I'm handling only structured data, the time required for me would be less. I have done some projects with in 3 weeks. So it is hourly cost for me. I'm a consultant, technology consultant, and data scientist. So for me, it's hourly charge. Uh, 3 weeks, 3 weeks, 8 hours a day. That's the cost. But some of the projects will have variety of data, as you can see in the big data world, the 4 V's. Um, One of that is variety. Uh, you have multiple different data, structured, unstructured, no link between data. I have handled some problems like some companies does not have a very good tech environment, does not record the data properly. There are different segments of data for you to understand, let's say different tables, but there is no common case at all. So you have to come up with relations and logics to merge, create merge keys, or somehow come up with some logics to bring all the data together, clean them. There will be a lot of ambiguities there. It is difficult. And then you have some information in PDFs, you have to extract it. Images comes in, you have to extract information out of it. It is a complex process. So time involved will be different. It depends on which problem you are actually trying to solve. So there is no like approximate fixed cost which you can say for a project. Uh, how can you handle with this? Is get an understanding of what's the problem, be clear on if this problem can be solved or not with machine learning or AI for intelligent automation, is and come up with how many people is needed, and try to get the sample data before you commit the project. uh, get the sample data and understand it, understand the the complexity there, meaning understand if it's clearly linked, how much data is missing, what's happening, understand the data. uh, like I would say veracity, accuracy of the data, understand it. And then come up with the resource requirement, decide how many people you need, how much time is required for those number of people, and then do an estimation. uh, Without understanding the data, estimating it will be a ruin. You would say like in a month or two you would do it, you will commit it, and then you will start seeing the problems in data. It's quite hard. I faced it a lot. Let me complete the presentation and then we'll take the questions because we're running out of time. So this is the last segment. Some of the important things which we should keep in mind while implementing any cognitive automation solution. Which main thing I would say from this whole, you can read it so it's easily understandable. Rather than explaining all these points, I let you read it while I speak about one or two here. Um, you should develop a strategy. Like intelligent automation is not something that you come up with. This might answer most of the questions people are asking here. It's not something that you find one problem and then you come up with a strategy. Strategy, how we are going to make your organization data driven, and what is the pipeline of projects you are going to do. Start with the low hanging fruits. Start with a very simple implementation. Keep keep optimizing it, keep enhancing it to the next level. That's how it should work. So it needs a lot of interaction between the business and the technology person. You have to interact with the stakeholders, you have to interact with on how much value it's creating. You have to interact with the users, you have to interact with all the people involved here constantly so that you can make sure you're improving your solution every single sprint. Um, Sprint is nothing but one next phase kind of. So if you're not doing it, it's not going to work. It doesn't work in a way like you find one problem and then you go fix it, and then your engagement with the client is done, then you start looking for different client. It can't be like that. If the company is not having a clear vision on what cognitive automation they are going to build, uh, they would not succeed likely, because after implementing it has to be monitored. Any cognitive intelligence solution, cognitive automation you do, cognitive automation needs cognitive intelligence. Machine learning, any machine learning you implement needs monitoring. If you don't monitor it, the models you build will become obsolete after a while when patterns change. That happens, and they still continue to use the deteriorated model, everything's going to screw up. You're going to lose your recognition. I mean, your name will be spoiled, because and the client will face a lot of loss if they keep using a model after it's deteriorated. There are techniques to find when the model is deteriorating, when it needs to be retrained. uh, you can search for it, it's easily available online. And other things are, people will be skeptical. That is one thing. You need to convey everything clearly if you are going to um, implement any of cognitive automation things, or any automation in any company, even basic automations. There has to be proper communication with all the employees and everyone, because there is a general myth that automation comes in, then people's job will be gone. So internally, there will be a lot of uh, cultural problems that's happening when you implement this cognitive automations or any automations. So that is a major problem which I have faced in many places. There will be no support from people, while whenever you reach out for information, which is very, very important on building this kind of cognitive solutions, you will not get what you actually look for. Though it is available, people will not like to share enough information. They will be like, internally, they won't support you. All these problems will happen. So the communication has to be very clear, very advanced. Like 2 months later, maybe I'm going to start a project on cognitive automation. We're going to try this, and it's not going to affect your work. Everything has to be communicated properly. Unless it's very hard, the cultural problems you face there uh, will not let the project to be successful. And the then what is important here? That's remaining is fine. Once you get the pipeline, you have to prioritize it. How do you prioritize the first, second, third processes you are going to automate? Prioritize it based on the cost benefits. There might be a slightly easier one, uh, but less cost benefits. There might be a little bit harder problem, but might give a better cost benefit. So if, why do we need to optimize it or prioritize it based on um, cost benefit returns? Is because with any client, only if they see returns, they will have more confidence. If they see no returns, if the first thing or the first two things they fail, they don't see enough value in it, they don't see enough value, then obviously they are going to be more and more skeptical towards cognitive solutions. That's almost all about it. uh, so as I said, it is, cognitive automation is the journey and it's not a destination. So it has to go on forever and keep growing. Let me take some of the questions here, and we are already running out of time, I think. Divya, how much time can I take for questions?
We can take around 10 minutes for the questions.
Okay, let me go through the questions. There is a question on how do I get a job as a data scientist or data analyst in management consulting firms like McKinsey, BCG, etc. Um, there's it's not only McKinsey, BCG, and everywhere. I work in one of the big four company. Uh, there's no hard ways which I can guide you. You can do it. If you're good in machine learning, you can become a data scientist, irrespective of what company it is. Attend, but maybe for these companies you need some years of experience. They might look for. How does this work? Is they either hire from campus direct. In your company, if you get that opportunity, that's better as freshers. Or if you are experienced, maybe few years, get stronger in the techniques behind, get stronger in your core, and then look if they are if there are any vacancies, then apply for it, go crack it. That's all. They are very open. With I only one thing I can say is the culture is very open here. They they will recognize you if you are capable of doing the job. So no other ways. McKinsey, BCG, any big fours, big threes, whoever it is, get stronger in your techniques, technical abilities and look for the opportunity, you will get it. What ML algorithms I use in most process automations? Okay, I I am a data scientist, much involved in machine learning, but all my projects are process automation. If that is the question, then no. I handle very less process automation problems with ML while I handle other ML problems. But general machine learning algorithms which I use a lot are first tree-based solutions, tree-based algorithms, XGBoosts, support vector machines, neural networks a lot. Um, Major ones, maybe all this. And then some time series-based methods like ARIMA models, ARIMAX, all these models. But there is no one model which I would use. Personally, I always prefer to go with ensemble of models, which are build multiple models and get a collective information from multiple models. If that helps, that's my answer for that question. Well, I can see the same question posted again and again. Which are the general factors which adds to the cost? Infrastructure for training, various factors for the same. This question is it in respect to cognitive automation projects? That's the case. Uh, the cost is on computation power, and the main cost is on resource. Uh, for any cognitive automation, there are less resources available, and they are costly. Data scientists are costly, so that's the primal cost, followed by computation power. I think I have answered most of the questions, and because there are repetitive questions again and again, and there are a lot of questions, I struggle to find new questions here. Okay, one person has asked, can you please briefly explain any process automation using suitable ML algorithms? Briefly give an idea of execution. Execution. Um, to, okay, you can start with having a dry run on the algorithms. One thing I would say is, like, if you have access to any ML automation tools, machine learning automation tools, for example, Decision Next or Data Robot, uh, you can go for it. The data Robot is on cloud. You can put your data in and ask that to run multiple different models, which will give you the sequence of models in performance. Then you can choose top 10 and start tweaking those algorithms manually, or you can start writing the scripts, play around with the scripts and tweak them. That's one way of executing, which many people follow, because it craves us a lot of time, but the impact is on the other side on computation. If you go for this kind of tools, they would charge you based on the number of cores you are going to use. So for big data, say you have a huge data on which you have to try everything, then you need a lot of cores. Then the money you're paying there will be higher. So there is a trade-off. That's one way of execution, which many people do here. Mm, how I would like to do it is, I would understand the data first. You would do a descriptive analytics on the data, understand its skewness, understand um, its veracity, its accuracy, the missing values, everything. Once I understand it, I decide on what imputations I have to do, what transformations I have to do in the data to come up with additional factors or columns which I need, and then I would do a correlation analysis to see what actually contributes to my target, and I would eliminate multicollinearity. Uh, After eliminating that, then I would start going building some of the models with the right features selected by appropriate feature engineering. And after that, I would have few algorithms heuristically, which I feel based on my experience that would help for this particular business. Um, and then I would try out a bit more. And then I would do a grid search on hyperparameter optimization for my algorithms. And I would run numerous architectures of the same algorithm to see which architecture does better. Then I would choose top 3 or 5 and ensemble them to get a final result. So that's my approach. You don't need to follow it, but it's just for your reference. What level of machine learning we need to know for such automation? Uh, if you look into the advanced automation phase, you need to know a lot of programming, maybe image processing, all these related things, language processing, text syntax processing, regular expressions, all those things. But you are looking into the intelligent automation or cognitive automation phase, then you should be very good in machine learning, because the problems which you will address will require higher understanding of machine learning. With basic understanding of machine learning, you can still build a model, but to productionize it, it's harder. The value, you may not see the value. So you should be in a position to deep dive and tweak wherever is essential, and you should be good in uh, monitoring it as well. You should be good in which metrics is in identifying which metric will be very useful for this particular problem, and you can't. There are many different metrics to monitor it, so you should be able to differentiate them, and you should know about which, for this case, what's my best metric. As much as building and deploying accuracy is important, it is also important to monitor the models which you build. So you should be very good in machine learning. Next question. Okay, that's almost all. So I think we are half an hour ahead. Like, we used another extra half an hour. Is that fine, Divya? So I think we can close the webinar now. You can reach out to me in my LinkedIn if you have any questions. I'll try and answer as early as possible, but I may not answer immediately.
Thank you, Hari. No problem. Everyone, I'm launching out a poll if you're interested in a data science course. And thank you, Hari, for taking up the session in depth and taking us through the journey of intelligent automation. We loved
Mhm.
hearing you, and thank you for all your support. And thanks everyone for being a part of the session and asking such wonderful questions. We'll see you probably next week with another webinar. And thank you for your time. I have got some responses in the poll. I want all of you to put in your responses, and then we have the final poll for your feedback of the session, and then we'll close down the session. Thank you.
Mm.
So here's the final poll of how did you like the webinar. Just put in the poll, and then you are free to enjoy the weekend with family or friends. Thank you guys. Bye bye. See you.